Welcome back to Rocket Can, my fellow space tubers. So today we have a very epic launch of the most rare and the most beautiful launch, which I also want to see. Very, you can say I'm very excited for this. The Delta 4 Heavy rocket launch, and specifically I am waiting for that fireball to occur, and that is the thing which I am waiting for just before the liftoff. So let's just have a look at what does it have in store for us. And here we go. So this Delta 4 Heavy will be launched by ULA, guys. ULA is the stands for United Launch Alliance, and this is their newest rocket which they are developing right now. This is Vulcan Centaur. This they are developing right now, and yeah, it has won some contracts for US Space Force on to be flown on this rocket. So yeah, it is being developed by United Launch Alliance. If you don't know United Launch Alliance is the only company which has been providing launch services from the starting of a US space agency like NASA. When they just started, then they wanted any rocket company to come and build rockets, then the United Launch Alliance was there. So it has been a very long journey for them, and it is a very you can say um, historical moment for them. And now let's just have a look at the Delta 4 Heavy rocket itself. Hi Mabula TV, hi River Racer, how are you? And here we go. So let's have a look at the rocket itself. So Delta 4, today we will be launching a Delta 4 Heavy configuration, but they also had this Delta 4 configuration, but this has been discontinued because this rocket, the you can say the work or the delivery, the payload delivery which was being produced by this Delta 4 M plus rocket is being done by Atlas 5 rocket, and that is much cheaper also. So that's why they have just discontinued this one. But yeah, this one is there, and this will also be discontinuing in like 4 launches are left for this rocket, and then it will discontinue. So let's just have a look at the configuration. So it has 2 side boosters, as you can see, 3 RS-68 A engine and 1 core booster. So basically what has happened, guys, here all those 3 are identical, no changes there. And okay, and that's why you must be thinking like, so okay, so there must be an asparagus configuration, so to let this fuel from these 2 tanks to flow into the main tank so that it burns for longer. No, there is no asparagus configuration. So if you don't know asparagus configuration, guys, asparagus configuration means you can say it is the most efficient configuration for a rocket. What will happen in that, the fuel from both these core boosters, the side booster, I would say, both the fuel from both the side boosters will flow into the main booster. So what will happen, uh, all the 3 engines will be run by these 2 boosters fuel, so they will deplete quickly, right? And when they will deplete, they will separate, and then we will have this 1 core boosters which will be fully fueled. That's the concept of asparagus configuration. Okay, so that's the most efficient one, but here we don't have that. So what so how they have overcome this problem, as in they need to have the this main core boosters to run for some time, right? So what they have done is, they just after liftoff, they'll throttling down the main engine, this the core engine, and that's why they'll be saving on fuel on that, because they have throttled down. So the engine is not burning as quickly as these 2 boosters are burning. So that's why the ISP, you can say, will ISP is not here. So yeah, ISP, you can say, is increased for 86 seconds more for the this core boosters, which means after separation for 86 seconds more, this core booster will burn. And then we have the interstage, then we have the second stage. Okay, so this first stage will be having the liquid hydrogen and liquid oxygen as its fuel, and then this will be the second stage is also a delta cryogenic second stage, and it runs on RL-10B2 engine. This also has liquid hydrogen and liquid oxygen as its fuel. Don't go for its size. It is very efficient engine. Almost it has an ISP of around 465 seconds. So what is an ISP? ISP is basically like a mileage of the rocket. Like we in our cars we have a mileage, right? In 1 liter, maybe it goes for 20 kilometers, 21. That's like, so ISP is like that only. More the ISP, more is the efficient rocket. So it has 465-second ISP. It means it will burn for that much time. That's the thing. Okay, so let's have a look at the payload, how much it can take. So low Earth orbit, see guys, that's the capacity of this, 28.3 tons. So that's the main, you can say, the heaviest rocket till now we have after Falcon Heavy. Falcon Heavy is the heaviest rocket, that's for sure. But it does not runs in fully expendable configuration. It reuses its booster. That's why its payload capacity decreases, because somewhere comes around this only 28.3 tons. That's the low Earth orbit. Geosynchronous orbit is 6.5 tons. Wow. And then Geo Transfer Orbit is 14.2 tons. It is the very heavy rocket, guys. It is very heavy rocket, you can say. So what is the difference between geosynchronous and geotransfer orbit? Geosynchronous orbit is nothing like, it is like, so let me just first tell you the geotransfer orbit, guys. Geotransfer orbit is that orbit in which the periapsis remains in the low Earth orbit, but the apoapsis goes to the geosynchronous orbit height, altitude I should say. Okay, so that's a transfer orbit, wherein after that the satellite goes to the apoapsis and burns its engine, and then circularizes to form to go into a geosynchronous orbit. That's a geosynchronous orbit. Okay, so geotransfer orbit is just pushing the apoapsis to the geo stationary orbit, and then geosynchronous orbit is not just pushing it to the pushing the apoapsis to the geo uh, stationary orbit, but they're going into that, and then after that reaching the apoapsis are again burning the engine and circularizing the orbit. So that's the thing. And I don't think so we have any rocket in my knowledge. Maybe they have, but in my knowledge we don't have any rocket which goes to a geosynchronous orbit, because engine restart criteria is a very crucial thing, and it results into a loss of uh, missions also. So we'll be having this 5-meter diameter fairing, and yeah, that's the thing. We don't be having any solid rocket boosters. So yeah, now let's just have a look at the mission profile. uh, so hi Mark, hi Mabula TV. So what does gyan means? Actually gyan means knowledge. It's an Hindi verb, or Hindi, I would not Hindi, it is Sanskrit, Sanskrit word in which the gyan means knowledge. So rocket gyan translates to rocket knowledge. So that's how. So this is the mission profile, guys. uh, in mission profile we only have this thing. I don't think so I have anything to show you in this. uh, so they have just made a thing for there this so yeah, of course, the launch time is 2:04 a.m. EDT. Launch period is this one. So they have around 152 to 6, around 4-hour launch window, guys. That's one thing. And we have 90% chance of launch today, because of the weather is 90% favorable, and this will be 141st missions of United Launch Alliance. Okay, so yeah, it's a very old company. Let's have a look at the payload itself. So oh sorry, where's the payload? I think so I have messed up something. Okay, no worries. So let me just put it once again in front of you. Just hold on a sec, guys. Here we go. So here we go. So guys, this is the mission profile which we'll be having. Basically, mission will be the ULA heavy lifter will carry a classified payload into an orbit for the National Reconnaissance Office. And the mission is named as NROL-44. This will mark the 12th flight of ULA's most powerful rocket since its debut in 2004. So guys, the payload which we are carrying is a spy satellite kind of a thing, or because the National Reconnaissance Office make that type of satellites. So we don't know anything about the payload, but what we do know is that the destination is geosynchronous orbit, which it will fuel by itself. The rocket will only transfer it to a Geo Transfer Orbit, and the payload is basically, as you can see, guys, will what we know is that it will be a spy satellite, and it will have a mass between 12 tons to 20 tons. That's all we know about it, and nothing else. So this is how the config the means fairing looks like. This is how big the fairing is, and I don't think so we have this much big satellite. Obviously the satellites comes in here, but we do have this much big fairing. uh, why do we have this much big fairing? That's all thing have to do with the aerodynamics. Okay, so yeah, this is the fireball which you will see, guys. This is the fireball. This fireball, I should say, let me just explain you when the things will start happening in the that time only. I'll explain you once. Do we have the stream now? Let's just switch over to the stream only. Let me just so yeah, mobility, it is going to the orbit. It won't be going to a geosynchronous orbit. It will obviously go to a geo transfer orbit, and from then the satellite's onboard engine will start on and circularize the orbit at apoapsis. So SpaceX got pushed back because of this rocket previous scrub. You can say that because they both have to manage those things, and obviously this is the national importance mission, so that's why obviously this has more priority. Hurricane is also playing a good role in that. Yeah, the payload is Space Force related. You can say that kind of say that, but it the National Reconnaissance Office morely, and in past also we have seen that they produce spy satellites only. So this is good. You can say it is a spy satellite only. So yeah, we are just waiting for the stream to happen, and once it comes up, I'll just pull it over to you. So till then, here we go. Okay, so that's a good thing, Mark. Just enjoying the weather and all. So, what time is in Australia? Is it night or is it uh, morning or what? So, yeah, the one thing which I should tell you that the launch will be happening in the night in the US. So, it will be around 2 4 a.m. EDT, which is night there, and that's why the thing won't be the fireball which you will see, the Delta 4 rocket fireball, which is this why this Delta 4 heavy rocket is known for. That won't be as much spectacular as much it would have if it would have been in the morning. But yeah, obviously the night has its own merits. we can see those awesome flames just rising up and glowing all the surroundings and all. So yeah, that's the thing. So just wait a sec for the thing to come in. Yeah, the one thing I should mention, guys, ULA released one thing, one you can say video about this Delta IV Heavy, not about this Delta IV Heavy, but about their missions and about all the history. And that was a 3D projection video which was projected on this live Delta IV Heavy rocket, which will be launched today. So that was very epic one. I think I should pull over to you also so that you can see that. Let me just see if I can do that or not. Just wait a sec. Okay. Yeah, here we go. Yes, I have uploaded that video, but if some people haven't seen that, so it is not like we can see that again, and we have some time also, so we can utilize that, right? Let's just have a look at it.
I'm Tori Bruno, President and CEO of United Launch Alliance. You are about to see the first ever 3D animated projection on an operational rocket. And of course, we have chosen the majestic Delta IV space launch vehicle for this experience. So enjoy the show, and God bless America.
We are dreamers, inspired by possibilities not yet imagined. Believers, driven to harness the potential of space. Leaders, combining expertise and ingenuity. And it all started with a spark of the imagination.
Go. SYS. Go. ESE. Go. Timer. Go. ECS. Go. QE.
This looks
Go.
so
USO.
real.
Go.
I will
OSM.
say
Go.
this has been
ESC.
performed very
Go.
accurately
ALC.
and
Go.
very
AC.
obviously
HQ.
some
Go.
glitches are there,
RC.
but that
Clear
could
to
be
proceed.
overlooked. And this fuel
Launch director. The launch vehicle is ready to launch.
fuel loading thing was very cool. I should say that.
Launch.
10, 9, 8, 7, 6, 5, 4. Main engine ignition. 2, 1, and liftoff. Liftoff of the United Launch Alliance Delta Heavy rocket.
Although ULA's focus is on the future, we will always celebrate our incredible legacy. 140 missions.
Like I can't even imagine
140 successes.
how could they have pulled up
enabling
all
our
this thing
customers
on
to
the rocket.
save lives, explore the universe, and connect the world. From John Glenn, the first American to orbit the Earth, to new ways of connecting the world. From the most accurate weather satellites ever deployed,
Mandatory evacuation for Central Florida.
to game-changing national security satellites and launching missions throughout the solar system and beyond.
Yes, Sohail, it's an American rocket which covers most of the NASA's launches.
To once again sending astronauts to space from US soil.
The Boeing Starliner, what they have you are looking is the Boeing Starliner. They will be launching on Atlas V rocket, that's why.
And doubling down on our commitment to our country. America has always and will always be at the forefront of space. This mission is no different. As we prepare to launch another critical asset to protect our way of life. The National Reconnaissance Office. When our country needs eyes and ears from the high ground of space, to give advanced warning to threats.
This thing was so cool. I must say that. Wow.
To aid in the aftermath of natural disasters.
And this fire also, how could they have just done this? I can't even imagine. This thing looks so real.
To answer our most pressing intelligence questions, it turns to the National Reconnaissance Office. The leader in national space intelligence systems.
And here we go for the Vulcan rocket.
The next
Launch vehicle is ready to launch.
ULA.
Mission directed.
3, Flight 2. We have ignition of the RS-68A main engine. And we have liftoff of the United Launch Alliance Delta IV Heavy rocket.
Execute, and we have indication of spacecraft separation.
Here we go, we have the stream, guys. Let's just have a look at those.
At Space Launch Complex 37, a Delta IV Heavy rocket is fueled and ready to launch the NROL-44 mission for the National Reconnaissance Office. Good morning. I'm Dylan Rice, a systems test engineer, launch conductor, and your host for today's broadcast. T0 is set for 2:04 a.m., and the launch team is working one issue that may push us into the window. A few seconds from now, at T-minus 4 minutes, the launch count will enter a planned 15-minute hold. We have 2 planned holds in today's 9.5-hour launch count. These planned holds give our team additional time to resolve any issues that come up prior to entering terminal count. At the request of our customer, today's live coverage will conclude following payload fairing jettison scheduled to occur about 6.5 minutes after liftoff. In addition to watching our webcast, you can follow live mission progress at ulalaunch.com. Will Ulrich, the 45th Space Wing's Launch Weather Officer, recently briefed the team on weather conditions here at Cape Canaveral. The probability of violating launch constraints is 10%. Ground winds are 5 to 10 knots out of the southwest, and the temperature is 81 degrees Fahrenheit. So the weather is within launch commit criteria and looks favorable for our planned T0 at 2:04 a.m. Eastern. Today's flight will take an easterly heading away from our Cape Canaveral launch pad. Let's take a look at what else we can expect to see this morning.
And liftoff of the United Launch Alliance Delta IV Heavy rocket.
At T-minus 14 seconds, the ROFIs, which look like sparklers, ignite to burn off excess hydrogen injected into the flame duct.
That causes the fireball.
ROFI ignition is followed by ignition of the starboard Delta IV RS-68A engine at T-minus 7 seconds. 2 seconds later, the center and port RS-68A engines ignite, generating more than 2.1 million pounds of total thrust to lift the rocket off the pad. This staggered engine start mitigates the fireball created by the hydrogen-burning Delta IV Heavy. Shortly after liftoff, Delta IV begins a pitchover to attain the proper flight path, while minimizing the pressure the vehicle experiences during flight. The Delta IV reaches Mach 1, the speed of sound, at 1 minute 18 seconds. 2 seconds later, the rocket experiences maximum dynamic pressure as it travels through Earth's atmosphere. At 3 minutes 56 seconds, the port and starboard booster engines shut down. 2 seconds later, the port and starboard boosters are jettisoned. The center booster engine then throttles to full power to maximize performance. Approaching main engine cutoff, Delta IV is traveling at more than 24,753 kilometers, or 15,381 miles per hour, is located 111 kilometers or 69 miles in altitude, and is 586 kilometers or 364 miles downrange. At 5 minutes 36 seconds, propellant levels deplete and the booster engine shuts down. 7 seconds later, the Delta IV separation system activates to release the first stage. The vehicle now weighs a little more than 5% of what it did at liftoff. At 5 minutes 56 seconds, the Delta Cryogenic second stage main engine burn begins. During ascent, NROL-44 is protected inside a 5-meter diameter tri-sector payload fairing. At approximately 6 minutes 38 seconds, the payload fairing is jettisoned. Delta IV continues its national security mission following payload fairing jettison.
Okay. So guys, here we are seeing the Delta IV Heavy rocket in front of us live from Cape Canaveral.
ULA is using the Delta IV Heavy configuration to launch the NROL-44 mission.
And let me just explain you a bit.
This is the 12th Delta IV Heavy launch and ULA's 141st mission. Delta IV Heavy is built in Decatur, Alabama, and it's our largest, most powerful configuration. It's comprised of 3 common booster cores, each powered by Aerojet Rocketdyne RS-68A engines, and a Delta Cryogenic second stage powered by an Aerojet Rocketdyne RL-10B2 engine. It's equipped with a 5-meter payload fairing, which you can see here. Events began July 27th when the spacecraft, encapsulated inside that payload fairing, was transported to the Mobile Service Tower at Space Launch Complex 37 and vertically integrated to the Delta Heavy rocket. About 6:30 p.m. last night, final preps began. The Delta Mobile Service Tower is 300 feet tall, 100 feet wide, and 100 feet long, making it as tall as a football field is long and as wide as a basketball court.
Okay, thank you.
It weighs about 10 million pounds.
Okay.
There are 40 hydraulic cylinders at pressures nearing 3,500 psi that raise the MST 8 inches prior to moving it back to its park position.
Okay, yeah, this is the mobile.
MST uses a carriage transporter system. It travels about a quarter mile per hour and takes about 25 minutes to roll the MST to the launch position 345 feet north of the launch vehicle. Delta IV stands 235 feet tall, or about 23 stories, and weighs about 1.6 million pounds fully fueled. The 3 big RS-68A engines produce more than 2 million pounds of thrust at liftoff.
Okay, thanks. So guys, I was telling you about the firepole. Let me just explain you what will happen today. So guys, this ULA pumps hydrogen.
Today's
into
launch is for the National Reconnaissance Office, or NRO. This is ULA's 29th launch for the NRO and the 8th use of the Delta IV Heavy for the NRO. The NRO is a joint organization engaged in the research, development, acquisition, launch, and operation of innovative overhead reconnaissance systems necessary to meet the needs of the intelligence community and the Department of Defense. The NRO is recognized for its transformational intelligence collection systems that are used to develop highly accurate military targeting data, support international peacekeeping and humanitarian relief operations, and to assess the impact of natural disasters.
Okay, so can I say now, Anchor? Okay, so I was saying...
Earlier this week, we had the chance to hear from the L-44 trajectory engineer, Corey Buckingham. Let's take a look at what he mentions is unique about the Delta IV Heavy and today's flight.
Okay, let's listen to him.
Hi, my name is Corey Buckingham. I'm the trajectory engineer for the L-44 mission. There's a few reasons the Delta IV Heavy is the only vehicle that can launch the L-44 payload. Primarily, it's the payload fairing. The ULA payload fairing is 65 feet long and 5 meters in diameter. That's about 16.5 feet. And it provides sufficient payload volume capacity for the L-44 satellite. The performance capability is the combined performance of the first stage and the second stage. As you can clearly see, there are 3 boosters that provide over 2 million pounds of thrust to lift the vehicle off the pad. It's going to be a brilliant show. I can't wait to see it. Now talking about the second stage, the DCSS, the Delta Cryogenic second stage, is a very capable and highly performing second stage. A big contributor to the second stage performance is the extendable nozzle of the DCSS. We launched the mission with the nozzle in the stowed position, and then after booster jettison, the nozzle deployment system extends the nozzle to its full length. This very long nozzle is a huge performance increase because of the increase in ISP, specific impulse. ISP is how we measure the efficiency of a rocket engine. It is calculated as thrust divided by the flow rate of the propellants. A great way to think about ISP is related to your car. Your car's engine, the efficiency is measured in miles per gallon. It's a very similar concept with rocket engines, and the high ISP, allowed for by the extendable nozzle of the RL-10, allows us to achieve the orbit of the L-44 payload. So if you're looking for someone to blame for the very early launch time, you can blame me. I'm the trajectory engineer, so I'm responsible for publishing the launch period. So how do we calculate the launch period? The time of launch is driven by the RAN, R-A-A-N, right ascension of the ascending node. The RAN is essentially a sun relative angle that the spacecraft requires us to achieve at spacecraft separation. So once we have the trajectory designed, the knob that we have to turn is the launch time. So we set the launch time to achieve the correct RAN. But then if you stop there, you have an instantaneous launch period. We want as long a launch period as possible to give us the best chances of launching on any given day. For L-44, we have a nearly 5-hour launch period. So how do we get there? Trajectory design incrementally steps out the trajectory until we reach the window open and window close time. That duration defines the launch period. Now these edge trajectories, they need to steer more and use more performance than the window optimal case in order to achieve the same orbit targets. We load specific guidance and navigation parameters depending on when we launch within the launch period so that robust guidance algorithms can get us to the correct orbit no matter when we launch within the launch period. This is just another factor of how the Delta IV Heavy can support the L-44 payload. Personally, I've been working on the L-44 mission for almost 4 years now, so I'm very excited to see all of our hard work come to fruition when it lifts off into the night sky.
Wow.
But more importantly, I'm looking forward to this vital asset to get on orbit and begin supporting the U.S. intelligence community, supporting national security space, and keeping Americans safe.
High River Racer, they use RS-68.
As I mentioned at the open of the broadcast, the team is working one issue. They're analyzing a temperature in one of the vehicle compartments, and so we are going to be extending this built-in hold until we have further information.
Okay, so I think there will be some. Okay, so there is some
As they do
problem
for
with
every
the
mission,
temperature.
the NRO provided unique artwork for NROL-44. Here's the story behind the art. The background of this artwork is a dark shade of NRO blue to symbolize cross-organization collaboration required for mission success. In the foreground, we see a wolf howling as a warning to its pack as the first point of detection for signs of trouble. The wolf pack represents the nation and the international community leveraging and supporting the steadfast sentry. Lastly, the falling snow represents the purity of the NRO's intentions and the serene calm of peace.
Yeah, High River Racer, they use RS-68A engines. Basically, Raptors and Merlin are developed by SpaceX and they have the right to use them.
A few moments ago, Mission Director Colonel Chad Davis remembered our friends and colleagues, Chuck Mitchell and Winnie Pang. Let's listen in.
This morning's NROL-44 launch is dedicated to the memory of Chuck Mitchell and Winnie Pang. Chuck and Winnie have dedicated countless hours of technical expertise, ensuring the incredible success of a multitude of launches. Their warm smiles, team spirit, and phenomenal leadership have rippled across the aerospace and launch communities. To our fellow patriots, rest in peace.
This is the onboard camera view which you can see right now. The ice is all there, which you can see. The white part basically is the ice on the rocket. This is the live view, I think, from the rocket itself. And we can see all those fumes coming out of the rocket. That is completely normal, guys, as it because it tops off all the hydrogen and oxygen which it gets. So if I get time, if we have time, let me just tell you about the hydrogen.
LC on 1 AC.
Go AC.
Okay, we have yet another ECS adjustment for you. This is for the inner tank. Currently it's 70 degrees F. We want to take that to 80 degrees F.
Roger. ECS LC.
Go.
Please take inner tank from 70 degrees Fahrenheit to 80 degrees Fahrenheit.
Roger.
Okay, so yeah, so this section is whole. The white thing which you are saying is because of the ice. That the rocket is not white at that part. That is because of the ice which that happens. And yeah, so the fireball, okay, let me just finish about the fireball. In the engines, they need to do an engine chill as well as to prepare it for the rocket ignition. So what they do is they pump in hydrogen into the cold hydrogen into the liquid fuel engine. They don't pump oxygen, and the reason is oxygen is more reactive than hydrogen, and it could damage the engine parts. That's why they pump in hydrogen, and after that, after some times, means 2 seconds before, they just release all those hydrogen. Okay, so what happens, since hydrogen is less denser than the air, it rises up from the engine nozzles, you can say that, and then the ROFIs come into place. What is ROFIs? ROFIs stand for radially outward firing igniters, if I'm not wrong. This is how it will, in simple words, ROFI is nothing but igniters. Okay, so the spark comes out from it. So because of that spark, the hydrogen which is coming out of the nozzles catches fire, and because it was rising also, so that's why we have a beautiful fireball coming just before the liftoff. We can see that just because of the hydrogen, and that sometimes leaves the rocket fully black and like burnt and all that because of that thing. So that is also completely normal thing, and that happens only in this Delta IV heavy rocket. And if you see that the rocket becomes completely black or there is excessive fire, it's completely nominal, as they say, nominal, so we don't have to worry about it. So Sohail Khan, the engine name is RS-68A engine, and if I'm not wrong, that's a Russian based engine, if I'm not wrong. Let me just confirm it once. Hi Fernando Rodriguez, hi Mohammed Rizki, and hi from Mexico. Hello guys, if you haven't subscribed till now, just you can consider subscribing if you want, because here in this channel you will find each and every launch that happens in the space industry. And tomorrow also we will be seeing one more pretty good launch of the Rocket Lab, and I'm very excited for this launch also, because that launch is a thing which will happen after the mission failure of their one of the rockets, and they have
This is Delta Mission
resolved that.
Control at T-minus 4 minutes and holding. We remain in the planned 15-minute built-in hold as preparations for launch continue. The team is still working through the temperature issue I mentioned earlier, and we'll get back to you with a new T0 as soon as we have one.
Okay, so we are at hold. So let me just update this thing. Wait a sec.
As I mentioned earlier, today's launch is ULA's 29th for the NRO. While we stand by and wait for that new T0, let's take a look at the huge role the NRO plays in the security of our country.
T-minus 3, 2, 1, 0. Ignition.
Oh, sorry. I was on hold. Sorry.
We are the agency that made the impossible possible, protected the world, and brought technology to levels undreamt of.
Go Centaur.
The race to space was a series of firsts, and we were there. We were the first to surveil our adversaries from the high ground of space, literally taking technology to new heights, watching our adversaries, guarding against the threat of nuclear war, and providing strategic advantage to our nation. We were the agency no one had heard of, because we worked in total secrecy. But we've stepped out of the shadows, and we are writing the next chapters of American space technology. We are the National Reconnaissance Office, the NRO, the world leader in our tradecraft, collecting top secret imagery and signals from space. Natural disasters threaten thousands of lives. Conflicts displace millions, and adversaries mount threats. We give advance warning, aid in the aftermath, protect our citizens, and safeguard the world. We are the only agency that develops these tools, partnering with the intelligence community, the military, and the best of private industry to drive innovation. We are the leader in space intelligence systems, the NRO. At the heart of it, our people who take satellites from idea to orbit, focusing talent and resources,
Naveen, I'll just answer your question.
building, launching, operating sophisticated NRO systems that help us maintain global vigilance 24/7, 365. Small sats made possible by miniaturization, reducing costs and expanding possibilities. Large satellites with capabilities designed to answer our toughest national security questions.
Wow.
Pioneering achievements on the ground, where analysts bring it all together. How do we do it? By investing in the latest research and development, using augmentation, automation, machine learning, and artificial intelligence, employing acquisition strategies to encourage competition, enabling us to work with the industry's best and brightest, like-minded people, committed to technology without limits. This is where careers rise to heights unimagined, where you can take your eyes and ears into space. We deliver, under budget and on schedule, meeting and exceeding expectations, to answer questions yet unasked. We develop new technologies every day and put them to use in record time in the high ground of space. No one can match us. The National Reconnaissance Office, the world leader in intelligence gathering. We are the NRO.
So, Naveen, basically this will launch. There is an halt at T-minus 50 minutes right now. The rocket launch has been put on halt, and the reason is there is some temperature issues in some, I don't know, he just mentioned there is some issue with the rocket and the launch pad. That's why they are just figuring it out, and once they figure it out, then we'll have a new T0, and then we will have a launch.
Continues to evaluate the issue and evaluate our new potential T0s. One of the other items that the team will be reviewing is data from the wind balloons that are launched from here at Cape Canaveral Air Force Station. Data from these balloons are used to generate a steering profile for the first 115,000 feet of flight. These balloons provide data on wind, temperatures, etc. that we use to design the pitch, yaw, and roll steering profile for early ascent. This steering profile is loaded onto the flight computer 30 minutes before launch. It can be updated within the launch period if our launch time is delayed. We have this capability on all configurations of our vehicles because it allows us to minimize the effects of wind shear, which reduce dynamic loads on the vehicle and spacecraft, and provides for more launch availability during periods of strong upper-level winds.
Okay, so and Naveen, they are using RS-68A engine, and very sorry for the mute. I think I was telling you everything and I was on mute. So guys, yes, I was telling you, if you haven't subscribed till now, you can just subscribe, because the next launch which I'll be streaming obviously will be of the Rocket Lab, and they are coming in after a failure of their rocket. Okay, they had a failure last time and they have just resolved it, and they'll be coming in hot. So what happened is, because there was some faulty electrical connector as the cause of the launch failure. Okay, fuel tank temperature was too low. Okay, hi Varisa, thanks for updating. And let me just tell you about the Rocket Labs, what went wrong with that for them. So they have a faulty connector which evaded Rocket Lab's pre-flight testing procedure, and basically you could define it as really a thermal fault. So while all of that testing showed no issues, after a period of time, one of the joints had a higher resistance, and that higher resistance led to heating. That heating then led to thermal expansion of one of the components, and that thermal expansion and heating allowed some of the potting compounds around that joint to keep it secure from vibration. Okay, so what happened was, when the rocket launched, that joints and all those things got, you can say, damaged or something like that, or faulty, because of the high vibrations during the rocket launch, and that caused a faulty connector in the electrical system, and that caused the problem, because they uses obviously the turbopump uses the rocket engine uses an electrical turbopump. So it needs electricity to run, right? So if it does not get that, obviously it will shut down, and that's what happened there. Before just getting into the orbit, all those things happened. So we are just waiting for the thing to, I think, don't know when this will happen. So let me just pull over Kerbal Space Program, guys, if you want. I have this Delta 4 heavy rocket ready on the launch pad there. Means not ready on the launch pad, but yeah, obviously I've that's ready in VAV, I should say. So should I pull over to that? So I don't think, because I don't know, I don't know when they will start on with the procedures. Let's just pull over to the, okay, so guys, here in this yeah, but they have resolved that issue, so they are coming in hot tomorrow. So obviously we'll be seeing that launch tomorrow of the Rocket Lab, and then after that we'll have a SpaceX launch also, and also obviously the Starship hop also. We have this 3-4 days are very 2-3 days, I should say, are very busy in the space industry. And this is a close-up of the rocket, and this looks so cool. Those are the nose cones, those are decoupler coupling kind of a stuff, and obviously those fuel vents which are keeping in check the oxygen supply to the rocket. That view was so cool. Sohail Khan, okay, so NASA is basically a space agency, of American Space Agency, I should say, and no, it's not in Australia. Hyderabad sir, what? As in what? The Rocket Lab is in Australia or what? Just let me just clear your question. So Sohail, what is NASA? You said NASA is basically an American space agency, and they have been a pioneer in the space race with the Roscosmos, I should say, the Russian space agency, and they won. Obviously, they won after their success to the moon. They landed the first person on the moon, And after that, it's not like the NASA was not there before that. It was established, NASA was established in which year? 1958. Okay, thanks for subscribing, Green Ecotex. Okay, thanks for subscribing, Green Ecotex. And then Rocket Lab. Yeah, Rocket Lab is an American private company. Yes, Naveen, you are right. But it's launches from a border, you can say, in New Zealand and America. It's registered in America, but it launches a rocket from New Zealand. Yeah, that's the thing. So it 1958, the NASA was established in 1958, and from there the mission for the NASA was to conduct science. From every mission they had there is to explore universe, explore how the universe became, how we are here, how the earth became, what was the big bang, what are the surrounding planets. Let's just explore them, and is there any habitable planet, or is there any life outside earth. So all those things was the mission of the NASA, and they were able to do that because they have launched so many missions to other planets, to other terrestrial bodies, and even there even one mission has left the solar system. So that's the thing. And obviously the space race boosted their potential with the Roscosmos. If you don't know about the space race, guys, space race, what happened in the space race, because of the US and the Russia Cold War, you can say they were having a war in the space. That I should say, whosoever reaches space fast and develops technology fast for the space wins the space race. That's what the concept. So initially Russia was winning the space race because they launched the first satellite, they even launched the first human, and every milestones which they had to perform, they launched that first. But the NASA, with just one launch, they overcome everything because they were able to develop a rocket and launch them to the moon. And let me just tell you guys, Saturn V till date also, the Saturn V rocket which launched the Apollo crew, till date also is the heaviest rocket ever built. Heaviest rocket ever built. We don't have any heavy rocket till now which can reach that potential of 104 tons. Obviously this Starship and this SLS system is coming, the space launch system is coming, but they have some time to come. But the Saturn V in 1960s, they were able to do that.
We continue to stand by for a new T0 while the team evaluates a thermal issue on the vehicle. While we do that, we'll take some additional views of the vehicle on the launch pad. There you can see the Delta logo with the number in the middle. The Delta rocket program has a long-standing tradition of noting the number of vehicles launched, beginning from the very first Delta rocket in 1960. The launch of NROL-44 will mark the 385th launch of a Delta rocket. Delta rockets have launched many of the world's vital space assets. Let's take a look at the impressive legacy of the Delta family of rockets.
Okay. So this is an Atlas 5? No, Delta 4 only. Okay. This is a Delta Heavy. And as you can see, this black, it has turned black, right? That's because of the fireball.
Though first launched in 1960, Delta's story really begins in the mid-1950s with the development of the Thor Intermediate Range Ballistic Missile. Named after the Norse god of thunder, Thor was created in response to a growing fear that the Soviet Union would beat the US in the deployment of a long-range ballistic missile. The goal was to design a system that could deliver a nuclear warhead to a target 2,300 miles away, the distance between the United Kingdom and Moscow. On January 25, 1957, the first Thor lifted off from the newly constructed Space Launch Complex 17 at Cape Canaveral. Following a series of early failures, the Thor team celebrated their first success on September 20th, 1957. In all, 59 Thor IRBMs were launched, with the last flight occurring in 1975. Thor began the transition from missile to space launch vehicle in 1958. On October 11, 1958, America's newly formed space agency marked its inaugural launch when Thor Able boosted NASA's Pioneer 1 on a mission to the moon, and NASA's long partnership with Thor was born. NASA and the Douglas Aircraft Company began development of the fourth and longest-lasting Thor configuration in April 1959. Using a Thor first stage and a Vanguard second and third stage, Delta I lifted off on May 13, 1960 from Cape Canaveral Space Launch Complex 17. Though its first launch was not successful, the Delta team quickly pinpointed the failure and 3 months later delivered NASA's Echo 1 communication satellite to orbit. Following Echo 1, the Delta team racked up an impressive 22 successful launches. Led by Bill Schindler, the Delta rocket earned its industry workhorse moniker for rapidly establishing itself as one of the most reliable and versatile launchers. During the 1960s, Delta launch vehicles paved the way for the burgeoning communications industry, launched America's first weather satellites, and sent probes to explore our universe. AT&T's Telstar 1, the first commercial communications satellite, launched in 1962. And in 1963, SYNCOM 2 became the world's first geosynchronous satellite. TIROS, or Television Infrared Observation Satellites, provided the National Weather Service with humans' first view of the Earth's cloud cover.
Wow.
In orbit around the Earth, Moon, and Sun, NASA's Explorer satellites provided us with a deeper understanding of the solar wind, cosmic rays, as well as Earth's magnetic field and radiation belts.
Yes,
By the end of the decade, launch vehicle modifications, including the addition of solid rocket motors and an upgraded third stage, made it possible for Delta to orbit satellites 10 times larger. The 1970s was an international decade for Delta, as the manifest included scientific and communication satellites for several countries across North America, Europe, and Asia. Perhaps the most demanding challenge of the 1970s was the launch of the Earth Imaging Earth Resources Technology Satellite, later known as Landsat. The mission for the Earth Sciences community required major changes to the Delta propulsion and guidance systems. During the 1980s, Delta continued its reliable service to the communications, weather, and Earth imaging communities. As capable as the Delta rocket proved to be, production came to a halt in the early 80s when national space policy dictated that the Space Shuttle be used as the U.S.'s primary launcher, signaling the end of the expendable launch vehicle.
Exactly.
But in 1987, the Delta team picked up where they left off, and development began on a launch vehicle to support the Air Force's Global Positioning System. On February 14, 1989, Delta 184 began a new chapter in space launch history as it lifted off from Space Launch Complex 17, demonstrating an incredible feat. The Delta II had gone from development to launch in just 2 years.
See the separation,
To
guys.
accommodate the larger GPS satellites, engineers improved the Delta rocket in several ways. The fuel tanks were stretched, a new payload fairing was developed, and larger solid rocket motors were incorporated. The modifications resulted in increased performance and flexibility.
That was cool.
By the mid-1990s, the Delta II had delivered the fully operational 24-satellite GPS constellation. And though it was developed for the Air Force, Delta again became a reliable partner to both NASA and its commercial customers. Over the course of its more than 20-year run, the Delta II has launched some of America's best-known scientific and exploration missions.
+4, 3, 2, we have main engine start. 0 and liftoff of the Stardust spacecraft. Liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
Liftoff of the Delta II with rail.
See the smoke.
To the center of the moon.
On the commercial side, Delta II launched the Global Star and Iridium constellations, which brought satellite telephone communication to the world. Continuing its evolution to meet the growing demands of its satellite customers, the Delta team developed the more powerful Delta III. Though short-lived, the Delta III doubled the performance of the Delta II.
Ignition and liftoff of the Boeing Delta III rocket. Stage systems looking normal. Engine burners keep burning normally, and all 6 ground.
In partnership with the Air Force's Evolved Expendable Launch Vehicle program, the Delta is a testament to the persistence, dedication, and commitment of an enterprising team that has continually evolved the Delta rocket to support a changing world.
5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Delta IV Heavy rocket.
Okay, that was a little bit, not little bit, was so cool. I didn't expect this much. So yeah, let me just answer your questions now. How much time it will take to launch Sohail? We don't know about how much time it will take since it is on hold and the team is working to resolve the issue. They'll also need to again reset all those parameters, the launch window, the trajectory and all, because everything will be changed once the the time is missed. Also the launch window we have around 4 hours, so yeah, we can wait till then, but obviously that long it won't happen. You wish to be a space scientist, Aman? Okay, cool. And NASA is not an idiot, obviously, Naveen. NASA is not an idiot. The space shuttle cost is high, 14 astronaut. Okay, so let me just tell you about this thing. So the thing is, the space shuttle, the problem with the space shuttle, I won't say the problem. First of all, let me just tell you about what were the merits of the space shuttle. First of all, it became the first reusable something. Okay, not it wasn't a stage of the rocket reusable first stage or kind of a thing, but obviously a reusable spacecraft. It became that, and they actually wanted a rapid release because they were constructing International Space Station with that, and they want one thing which they don't want to they don't need to make again and again to launch that, and they can just reuse it, and it has a very big capacity and it is reliable also. So they came up with space shuttle, and the thing with the space shuttle was the heat shield. I should say the con. I should say now the heat shield, the black heat shield below it was literally, you can say, not not even screwed, though they were if you have seen space shuttle, those black, they are like some tiles on the shield on the space shuttle, right? And those tiles kind of a thing are just glued, or you can say literally pasted on that thing. They are not even screwed, and that caused issues. The incident with the Kalpana Chawla's space shuttle launch, or loss, I should say, uh, that happened because of that only. What happened was there was excessive frosting on the ice. Yeah, excessive frosting of ice on the fuel tank. As you can see, we have frosting, right? In the Delta for heavy rocket also, we can see those white frosting there. So that was there in that also. And after that, because of that, what happened when the rocket lifted off, one piece of an ice came, and since you know the rocket speed at that those levels are very high, almost around 2 times or 3 times the speed of sound at that time. So because of that, as the speed was very high, the frost or that came out of the fuel tank and hit one of the heat shield, and it damaged literally around 5 to 6 tiles, okay, of the heat shield. And since we don't need heat shield during the liftoff, there was no problem with that. We were able to go to the International Space Station. They were able to go to the International Space Station and conduct all those experiments and science, and everything was fine. But then, after when they re-entered the atmosphere to reach the Earth, heat shield was the main thing to protect them, right? So at that time that thing happened. So let me just tell you, below the heat shield there was aluminum, and aluminum has very less melting point. So what happened, since aluminum was exposed, that thing came to fire and was melted because that was exposed. And when it re-entered the atmosphere, because of all those re-entry effects, the heating and all those things, there was no heat shield to protect it. That aluminum got damaged, and that part got damaged, melted or blasted or something like that, and we lost the crew. That thing happened because of that. Another incident which happened because of the space shuttle was the thing, I should say one thing only for that. The loss of the crew for the second time was not because of science but because of the political pressure. I should say that, because the mission director and all were like, we should not launch at this time, this is not the right time, we haven't tested this much and all those things. But there was some pressure from the above side, and that's why they had to launch at that time.
This is Delta Launch Control at T-minus 4 minutes and holding. The team continues to work through a lower than expected temperature condition in one of the vehicle compartments and has not selected a new T0 at this time. No matter when we lift off within the launch window, the trajectory is fixed through payload fairing jettison. A fixed ascent profile makes the range safety analysis more straightforward because areas that are clear do not have to change if the launch times move within the launch window. Robust guidance algorithms make corrections later in the mission in order to achieve the target spacecraft orbit. These guidance algorithms account for all the mission constraints, which could be structural or thermal, for instance, how long the spacecraft spends in the sun, and adjust the duration of each of the 3 main engine burns to ensure that the spacecraft arrives where our customer wants it on time.
Okay, so yeah, I was telling you about that, the second loss. Second loss occurred because of that pressure from the higher authorities. The mission director and all those people were saying it's not a good time to launch, we haven't tested and all those, but they had a pressure, so they had to launch. And because of that, what happened, as you know, the space shuttle had 2 solid rocket boosters, right? When it went in flight, there was one anomaly in one of the solid rocket booster. Okay, there was one anomaly which resulted in fire in, you can say, a lower part of the solid rocket booster. And there was some leak, I should say. We can't have a leak in solid rocket booster, but you can say a leak of the fire, I should say, in one of that. And because of that, there was full blast. Okay, and that blast caused the space shuttle to fully destroy. I should say the second time they were like not fully destroyed. Whatever the crew, whatever they had, the leftover part of the space shuttle they had, they were trying to maneuver it and trying to get over it, like as maneuver it, pilot it, whatever you can say. They were trying their best, but sadly they weren't able to do that. And obviously they were like, they had to jump in midair to the sea, and they were never found then. So they were declared that dead. But in the telemetry and all those said that they were alive for some time, switching over to the oxygen pumps and all. But yeah, we were never able to find them. So that's the thing. And That's the thing about the space shuttle. So it wasn't a thing which should be like it was like very bad or something. No, every rocket has its failure, right? Everything has its failure, and the space shuttle had only two failures, and other rockets had so many failures. Like Falcon 9 itself had three failures, and then they were successful. So, and after that also they had two failures. So rocket always had some failure, have some failures, and because of that failures only the thing improvements come in, right? They come to know that yeah, okay, this thing can also happen, and then the improvements come in. So what they did after the Kalpana Chawla's incident, after every launch, not yeah no, they missed that opportunity also. One more time that happened, guys. One frost kind of a thing came out and he hit the heat shield, but the crew was safe because the exposed part was steel, and steel could bear those re-entry temperature, and that's why they were able to save those crew. And after that incident, the second time when it happened, they were like, you can say, alerted, and after that there was some procedure only before the space shuttle was come home after come home from the ISS. They need to do thorough inspection of this space shuttle, and if there is nothing anomaly or nothing any problem with that, then they can proceed with the re-entry that was introduced. Okay, so that's the thing. And space shuttle cost was not high because of the reusability. Yeah, it basically it wasn't high at that time, but it became high when they had to maintain. Actually, the maintenance cost of the space shuttle was going up and day by day, year by year, because it was launched. It was the first space shuttle program was launched in 1970s, if I'm not wrong, or 1980s, and it continued till 2011. So the maintenance cost went keep on rising, and that's why the space shuttle had a very uh, resulted into a costly spacecraft. NASA currently does not have any launch vehicle of itself. They are currently developing a space launch system, which will be a very heavy rocket comparable to the Starship, and that will provide all those launch, the Artemis mission, which they are planning to, the Artemis mission, the NASA's Artemis mission. And this Artemis mission is basically going to the moon again after uh, 30 to 40 years, 50 years, I should say. Yeah, 50 years. We will be going back to the moon with the crewed spacecraft, landing to the moon and conducting experiments. But this time, not because of the space race, but this time to stay. And we'll also have the first women who will land on the moon. So yeah, that's the thing which is coming in 2024. They are planning to do the main landing, but before that we obviously have some big milestones which NASA has to achieve. And coming in hot next year only, we will be seeing one of the missions, Artemis 1 mission, which will happen, which will won't be a crewed spacecraft, but it will be a spacecraft in which it will just have a flyby or maybe have an orbit of the moon, and then came back to test all those things that it is working correctly or not. So yeah. स्पेस शटल को रिटायर क्यों किया कि वो मून तक चला गया था तब भी इसलिए किया क्योंकि उसकी कॉस्ट बहुत हाई थी. Actually, the Saturn 5 was retired because of its high cost, basically, and high cost and high, you can say, technical difficulty for making it. It had millions and millions of parts in just one rocket, and that's why it was very difficult to make, and that's why we didn't make anything again compared to that, because we did, first of all, there was no need of it. Second of all, uh, Saturn 5 was very costly to make, and this space launch system we are making, because again we are going to the moon, there is one need to do that. That will be comparable to that, means that won't be that much costly as Saturn 5. Kalpana Chawla was filming it as they broke up. I don't know about it, but if they were, that was very saddening incident. Smoke which is released from rocket is harmful or not? Well, this is a question which needs to be discussed a lot. Let me just tell you in just a bit. Just wait a sec. Basically, guys, obviously the pollution is there.
This is Delta Launch Control at T-minus 4 minutes and holding. The team continues to work through a thermal observation in one of the vehicle compartments that does not match pre-launch predictions. And we are awaiting a new T0. Whenever we have issues like this come up, the anomaly chief, who you will hear polled in the final countdown, will form a team comprised of ULA engineers, both here at the launch site and, if required, back at our design center in Denver, Colorado, to talk through the issue. As part of that team, the United States Space Force has engineers represented in that conversation as well. And if it's an issue that comes up and could potentially impact our spacecraft, the spacecraft team is invited to participate in that discussion also. During that discussion, the team will work through current observations and potential troubleshooting steps if required. The entire team will concur on a go-forward plan that will allow the launch to proceed or provide additional data with respect to the given condition. And once the entire team agrees, the team will either proceed with the count or proceed with troubleshooting as prescribed by the anomaly team. Once the issue is resolved, the anomaly chief will come to Net 1 and provide an outbrief to the launch director and the mission director and the launch conductor, indicating that the condition has been resolved and operations can proceed for launch.
Okay.
So we'll continue to stand by while the team talks through the thermal concern, and we'll provide updates as they are available.
So guys, the update from the launch is that they have resolved the issue, and now they are just resetting the countdown and maybe taking all the data and being double sure that everything is being resolved correctly. So the thing is resolved, but they are being double sure and checking all that. So yeah, the question for are the rocket fumes or the rocket smoke is harmful or not? See, it all depends on the composition of the fuel which you are using. Okay, so if you are using hydrogen and oxygen only as the rocket fuel, then the exhaust or the thing which it is gives is water only, and water is not harmful, right? So that's the thing. So, and if you are using solid rocket booster,
Go LD. LC at this time, please load new target set, segment Bravo. Roger. Flight control, LC, Net 1.
This is flight control.
First step 1450. Load contingency trajectory using autofile FPCS D Delta Victor 041-002 _ Charlie Alpha Sierra Echo _ Bravo. And revised guidance STL CRC is 5 Delta Charlie 8.
Roger. In work.
Okay. So I think, well, okay, so let me just tell you. So yeah,
this is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the launch conductor gave the order after direction from the launch director to update our some of our guidance parameters. We spoke about that earlier in the feature with trajectory engineer Corey Buckingham. As we proceed through our launch window, there are certain points that we will reload new guidance parameters, ensure that we have an optimal flight to the spacecraft's target orbit.
Okay. So, yeah, I was telling you about the smoke. So it depends all on the fuel only, guys. If you are using a fuel which is more cleaner, like as in the vehicle of the cars, right? If you are using a cleaner fuel in the vehicles, not diesel, not petrol, like using natural gas or something like that, it is more cleaner. So it causes less pollution. So that's what it is in the rocket industry also. If you are using a cleaner fuel, then no problem. But yeah, the solid rocket boosters, obviously they cause us a lot of pollution, and basically I should say that the soot which comes out of the rocket, that accumulates in the upper stratosphere of the atmosphere, where the particles absorb sunlight. Okay, and this accumulation heats
LC
the
flight control.
Go flight control.
Contingency trajectory has been loaded using autofile FPCS Delta Victor 041 002 K _ Bravo with a revised guidance STL-CRC of 5 Delta Charlie 8.
Roger.
okay. So yeah, I was telling you about the accumulation which occurs in the upper stratosphere, the rocket suit accumulation. This accumulation heats the upper stratosphere, changing the chemical reaction rates and likely leading to ozone loss. So yeah, everything has its demerits and merits. So but I don't think so it causes much of an issue, because obviously we are having a lot and lot rocket launches now. But if we are through with the fuels, not using the solid rocket boosters, and basically the solid rocket booster does cause most of the problem. Other thing can be resolved, but the solid rocket boosters causes some problem. That's the thing. If we stop using solid rocket boosters all over, then obviously the this pollution kind of a thing will be resolved. Naveen, it wasn't a big mistake. Space shuttle wasn't a big mistake. It was a huge success, I should say. Only two failures it had. Other rockets have so many failures, but it only had two. Yes, High River Racer. The second was not because of any technical issue. It was because of those things, weather and all. It was not supposed to be alive. Yes, High River Racer. They were alive until they hit the water, and we don't know what happened after they hit the water. Yes, Naveen, they used the NASA used the space shuttle engines in SLS. And why did they use? Because they are very highly reliable engines. They haven't failed. The reliability, they have failed in once, but the reliability of this engine is 99%. Okay, and that's why they want to use it, because it is so much tested, so much reliable, and so much, you can say, so much of thrust it can produce also. Yeah, that's also the thing. So that's why they want to use, because it is reliable. And for the crewed launch, obviously they want something which does not fail, and this space shuttle engines have proved that. And why not use something? Obviously, the thing is, these RS-25 engines will be optimized for the space launch system. But yeah, if they had any innovation for some new rocket engine, that would have been much better. But it's okay, they are going with that. Yes, High River Racer, the space, actually the cost come way less than what they expect when they can reuse something. Because think yourself, just making hold those plain like of a thing again and again and again.
This is
How
Delta
much
Launch
cost would it
Control
take?
at T-minus 4 minutes and holding. The team continues to work through the thermal issue I mentioned earlier. So while we're waiting on that, we'll take you through some additional shots of Launch Complex 37. This is a wide-angle shot. On the left-hand side of the screen, you can see the fixed umbilical tower with the 3 swing arms reaching over to the Delta IV Heavy vehicle. In the background, you'll see a flame. That is a hydrogen flare stack, so gaseous hydrogen that is basically evaporating from the liquid state gets burned off through that hydrogen flare stack. It's actually quite a bit of distance away from the launch vehicle, so even though you're on your screen, it may look very close to the launch vehicle. There's actually quite a bit of distance there. And then off to the right side of the screen is the mobile service tower I mentioned earlier.
And obviously, those are the launch.
Here's a view of one of the Delta's onboard cameras. This camera is on the second stage looking down. And here's a closer view of the launch pad and the swing arms. On the opposite side of the vehicle, you can see gaseous liquid oxygen as it's escaping out the oxygen vents. At this point in the count, the liquid oxygen will be replenished as liquid oxygen evaporates into the gaseous format and comes out those vents as you see there on the first stage.
Exactly. So guys, if you have any other question, you can just ask me. I'll try to clarify as much info as I have. Yes, please, but they are not interested in it. High River Racer, because that is not on a priority list right now. Obviously, they are in a state like they have mission to reuse all of the parts on it, but they are right now focusing themselves into a bigger picture, and that is the development of Starship. They are right now not focused on the bringing the second stage itself. That's why they are not doing something about it. But yeah, obviously they are doing many things for the Starship, and we will be seeing soon another Starship hop, 150-meter hop, in a day or two. So if I am awake at that time and if I am able to see that, then obviously I'll be able to stream that also. So just be with me and you'll find everything here in this channel only. Not only SpaceX, but ULA is also thinking for the reusability for the Vulcan. They are thinking for reusable the second stage. They will be literally fitting in heat shield, inflatable heat shield for the second stage, and try to retrieve it. Yes, High River Racer, they will. Obviously, they will. The sole purpose of the Elon Musk's reusability will be lost if they want to reuse the second stage also. So yeah, they will be reusing it. No worries for that. But firstly, they are working for the Starship. And once it is accomplished, then all those things could be looked for. And anything else you would like to ask, you can ask me. But till then we can. Okay, so till then we can view that thing which we left in half only.
This is Delta Launch Control at T-minus 4 minutes in holding. We continue to evaluate the thermal issue on the first stage of the vehicle and are standing by for a new T0. We've created a short tour of our launch locations here at Cape Canaveral in Florida. Let's take a look around.
Okay.
With missions launched to every planet in the solar system, as well as critical national security, science, weather, and communication satellites, ULA has established a long-standing reputation for reliability and orbit accuracy in the space launch industry. At our launch site in Cape Canaveral, Florida, the story begins with ULA's Atlas and Delta rockets arriving on the RS rocket ship. The rocket ship is a specially designed cargo ship used to transport rockets from ULA's 1.6 million square foot production facility in Decatur, Alabama. Rocket ship is large enough to carry a complete Delta IV Heavy rocket. That's 3 boosters, a second stage, and a payload fairing. Once loaded, rocket ship departs ULA's dock and travels through the Tennessee River, then onto the Ohio and Mississippi rivers, then goes out into the Gulf of Mexico. From there, the ship travels through the Atlantic Ocean, around the southern tip of Florida, and north to Cape Canaveral. Rocket ship was designed with several features to ensure successful delivery, including the ability to adjust its draft for shallow water and rudderless steering, which minimizes the need to tug. Atlas V boosters are transported from the ship to the high bay in the Atlas Spaceflight Operations Center, or ASOC, for final preparations. Delta IV boosters are moved to the Horizontal Integration Facility, or HIF, where they are mated together to form the Delta IV Heavy configuration. With final checks completed, the boosters are transported to the launch pad for Launch Vehicle on Stand, or LVOS. The 107-foot-long Atlas V boosters are brought to Space Launch Complex 41 and are hoisted into a vertical position using a crane and placed onto the Mobile Launch Platform, or MLP, in the Vertical Integration Facility, or VIF. Delta IV Heavy rockets are raised vertically by a fixed pad erector at Space Launch Complex 37. The fixed pad erector uses a single hydraulic piston to rotate the boosters 90 degrees inside the Mobile Service Tower, or MST. LVOS is followed by the addition of solid rocket boosters, and then the second stage. Next comes Wet Dress Rehearsal, or WDR, which is an end-to-end launch simulation, from fueling through spacecraft separation. Meanwhile, the ULA team is also working simultaneously to help the customer encapsulate their payload into the rocket's payload fairing. The encapsulated payload fairing is the final piece to be mated to the rocket. With the rocket stack complete, the spacecraft team tests all of the interfaces with the rocket and the launch pad. Once the rockets are completely assembled, final launch preps begin. For Atlas V rockets, launch countdown begins with moving the rocket from the VIF to the pad. The quarter-mile trip uses 6 components to complete the 20-minute trip. Weighing in at about 2 million pounds, the MLP supports the rocket and contains air conditioning, electrical, and commodities, while the undercarriages bear the weight of the MLP and rocket. 2 rail cars lead the move, with the payload van providing communication to the payload, while the ground van houses the ground support for the rocket. At the rear of the convoy, the portable environmental control system provides air conditioning to the payload and rocket. Finally, track mobiles provide the power to move the 3.5 million pound convoy. For Delta IV Heavy rockets, the process looks quite different. Approximately 9 hours before T0, final preparations begin as 40 hydraulic cylinders at pressures nearing 3,500 psi move the 10 million pound MST. It's first raised 8 inches and then rolled back. Delta uses a carriage transporter system, traveling at about a quarter mile per hour. It takes about 25 minutes to roll the MST to its launch position, 345 feet north of the Delta IV rocket. The Delta IV rocket stands 217 feet tall, or about 21 stories, and weighs more than 900,000 pounds fully fueled. On the day of launch, nearly 30 engineers and managers are polled for system status and readiness to proceed.
Status check to proceed with terminal count, Atlas Systems, propulsion.
This is the final status check before launch for all Atlas and Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants.
Range coordinator. Clear to proceed. Launch director.
Launch vehicle is ready to launch.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count.
If the rocket is ready for flight and the weather is within the launch commit criteria, then polling will be completed and the team will have given the go for launch.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There's ignition. And liftoff of the United Launch Alliance Atlas V rocket.
For a typical Atlas V flight, the main engine and solid rocket boosters ignite to lift the rocket off the pad. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path, minimizing the dynamic pressure the vehicle experiences during flight. Within the first few minutes of flight, the vehicle reaches Mach 1, the speed of sound, followed by jettison of the solid rocket boosters. About 4 minutes later, propellant levels deplete and the booster engine shuts down, followed by release of the booster stage. At various times in flight, depending on the mission, the vehicle jettisons its payload fairing. From there, the second stage will continue carrying the spacecraft towards its destination with planned engine starts and stops. Finally, Centaur will release the spacecraft in its target orbit to continue its journey.
Yes, hi River Racer, you are right. I should have pulled on the Kerbal Space Program till now. I think I should do now. Wait a sec.
LC1, this is AC.
Go AC.
I'm ready to brief the concerns for the OCU temp.
Roger. LD Net 1. LD. MD Net 1.
MD.
Proceed AC.
Okay, the team did some very thorough reviews and ran some models. Based on that and our analysis, we have a conservative prediction from the models, and it generated sufficient margin. Plus, looking at our flight trajectory will be mainly in sunlight, so that helps the situation as is. Our recommendation is to proceed, that we have no concerns with these current temps in the OC.
LC concurs. LD. LD concurs. MD.
MD concurs.
Well, it looks like something has happened. I think they have resolved all this issue and reviewed the data also. And now we are looking forward for a new T0. And once it happens, then voila, the thing will be good.
This is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the anomaly chief provided an out brief on that anomaly with concurrence from the launch conductor, launch director, and mission director. So in just a short few moments, we'd expect to be hearing a new T0 from the leadership team. So we'll stand by.
Okay. And let me just pull over the Kerbal Space Program. Oopsie. Just wait a sec. Why is it saying like this? Come on, man.
LC, LD channel 1. Go LD.
Yeah.
LC, please coordinate a new T0 of 07:28:00 Zulu. Roger, 0728:00 Zulu. Good copy. ALC, please set the clock for a T0 0728:00.
Roger.
RC, LC.
RC.
Please coordinate with the range, new T0 0728:00.
0728:00 Zulu in work.
This is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the launch team is now going to target a new T0 of 3:28 a.m. Eastern Time. The assistant launch conductor will reset the countdown clocks for the new T0 while the range coordinator goes to the eastern range and verifies the eastern range can support that new T0.
Okay, so it's in around, let me just
LC,
check the
RC1.
Go.
Range is approved, new T0 0728:00.
Roger.
LC, ALC.
Go.
Countdown clock has been set for a new T0 of 0728. We're currently at L minus 24 minutes.
Roger. All right, team, the clocks are set, and we have an approved T0 at 07280.
Okay.
This is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the new T0 has been approved, the clocks are reset, and the clocks are now counting down towards a new T0 of 3:28 a.m. Eastern Time.
Cool. Alright, what the hell? Let me just set this timer. Once it is set, then we are all ready to go. 7:30 is not 7:30. It's 3:28. I think that's the Pacific time they are talking about, if I'm not wrong. But it's 3:28. Arey man, what the hell has happened? Come on, come on. Open up. Let it be like this only.
L minus 23 minutes.
Okay. What I can do, yeah, obviously. I can do this thing. Oh, I see. Yeah. Everything is good now. Finally. Okay, now we can have a... So guys, we are 22 minutes from the launch. Until then, we can obviously play this Kerbal space program and do whatever we want.
This is Delta Launch Control at T-minus 4 minutes and holding. As you can see on your screen, this is a view from the Launch Control Center at the Delta Operations Center. The team in the LCC is responsible for the final pre-launch checkouts, fueling, and launch of the Delta IV Heavy vehicle.
Okay.
This is the Mission Director Center, or MDC. Within the MDC, you'll find the ULA Launch Director and the NRO Mission Director, who you just heard as they received an out brief on the anomaly we have been working and then provided direction on that new T0. Here's a view from our DOSC, the Denver Operations Support Center. These are engineers that are responsible for the design and operation of the various subsystems on the vehicle. These engineers would have been engaged in the anomaly discussions and in the analysis that you heard referenced as the anomaly chief provided the out brief on that anomaly we worked a few minutes ago.
L minus 21 minutes.
Let's just quickly launch this thing in our game only. We'll come back again, but let's just quickly launch here. Everything is ready, we just have to launch, right? So we have 20 minutes, we can obviously launch that. So guys, I've already made the Delta IV Heavy. We have that, right? Let's see. Will be putting in on the... Okay, let's just see if I can put on a satellite only. Open. And this is the thing.
This is Delta Launch Control at T-minus 4 minutes and holding. As you heard a few moments ago, the range coordinator went to the Eastern Range to request approval for a new T0. ULA collaborates with the Eastern Range to prevent launching at a time that would result in the vehicle colliding with the ISS, another satellite, or catalog space debris. Our trajectories in the launch window are provided to the Space Force for analysis prior to launch day, and we're given a report several hours before launch that indicates if launch on a given minute within the window will have the rocket or payload flying near an object with a high probability of contact. This report is called a COLA report, which is short for Collision on Launch Avoidance Report. The mission director reviews the report and lets us know if there's a particular minute that we should not target for a T0. In this case, the targeted T0 was clear, our T0 was approved, and we are counting down toward a launch at 3:28 a.m. Eastern Time.
Okay. So guys, here we are at the launch pad. We weren't able to see the launch for this yet, but obviously we can simulate that in Kerbal, right? So here we are, the launch pad, and let's just have full throttle, not. Let's just go for full throttle. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition and lift off of the Delta 4 rocket. Right? This does look like a Delta 4 rocket, right? Delta 4 Heavy, I should say. Oh, didn't I change the... Oh, sorry. I didn't change the transmission. Sorry. Yeah, so guys, this is a Delta 4 rocket carrying the payload, going on for the gravity turn here, performing the pitch maneuver. Looking good. This does look like, man, this does look like Delta 4. So now guys, right now I'm doing a pitch maneuver, which is basically needed to get into an orbit. If you just want to go straight into the space, you can go straight up and then come down. But if you want to stay in space, then you go straight up and then sideways, and that's what I'm doing right now, going to a Jio Transfer Orbit. The high revelation now you can see, right? I forgot to change the scene, but yeah, now you must be able to see it properly. Everything is looking good. So we are approaching this first stage engine cutoff, the side engine boosters cutoff, and then decoupling of that. That is, as we all say, right? So right now this is the max Q. People is experiencing max Q here. And now
ULA provides the analysis used by the Eastern Range to produce stay-out zones for airline pilots and boat captains on day of launch. These stay-out zones prevent intentionally jettisoned rocket pieces from landing on airplanes and boats. The Eastern Range will produce NOTAMs, or notices to airmen, to indicate to pilots that the airspace around Cape Canaveral Air Force Station and along the launch vehicle's flight path should be avoided. In the event an aircraft enters this controlled airspace on launch day, local air traffic control will contact the aircraft and direct them out of the area.
Okay.
The range also produces notices to mariners to provide the same information to boaters. The U.S. Coast Guard will post these notices at local ports and boat ramps. United States Air Force, NASA, or U.S. Customs and Border Patrol aircraft or U.S. Coast Guard boats may intervene if boaters enter the controlled sea space and do not respond to attempts to communicate. This is Delta Launch Control, T-minus 4 minutes and holding.
Okay. Thanks for the update. Now we are moving in and cut off. Oh, here we go for the jettison of the side boosters, guys. And now we are going on with this thing. Right now, obviously this is also max Q effect, getting in from the upper atmosphere with high speed, and that results into this. This is how it will happen only in the real scenario also. We will be only seeing the till the payload, the fairing jettison, and after that we won't be able to see it. And we are
L minus 14 minutes. As gas LC.
Okay.
Go LC. Establish scan pattern 140. Roger. VSE LC net 1.
VSE on 1.
Verify base bending moment instrumentation is active and data is valid.
Verified active. Recommend placard 6 Alpha for launch.
Roger 6 Alpha. OS LC.
OS.
Set BBM active.
Roger.
What is it going on there? Just have a look at it. Okay. So we are going good here. Like, can switch over to our turbo, and here we go. Oopsie. The main engine cut off and the jettison of the main engine. And now the second stage is going on. This is how the second stage of the Delta rocket looks like, guys. I am aiming for around 80 or 100 kilometers in orbit. Here we go. Now we'll have a fairing jettison soon. And fairing is jettisoned, exposing the payload. Right, guys? Now we can perform a maneuver here.
All personnel, check your mics on that one.
L minus 12.
MEQ, initiate retract data logger just prior to the L7 pole.
Roger.
We have an open mic on net 1.
Don't worry, this won't rotate like this in real life. Don't worry about it. It's here only that it is rotating like this. Now going to the maneuver node and accelerating towards Jio Transfer Orbit. Okay, so you will be able to see also how does that Jio Transfer Orbit looks like. Just
L minus 11 minutes. SYS, configure flume on for PU shadow mode.
10987.
Flight control, configure option 910 for PU shadow mode.
Roger.
Let's let's just go on and on and on with the increasing the apoapsis. Let's just go on with that. And there we go. Oops. So here we go in the Jio Transfer Orbit. So guys, this is how a Jio Transfer Orbit looks like. Herein we increase the apoapsis to a geostationary orbit height. This is not an height of the geostationary orbit. That's around 2.
L minus 10 minutes. All communications switch to channel 1.
This is how
All
it will
personnel and
happen,
visitors
guys.
remain in present position until launch. Maintain
now
operational silence in the LCC.
We can switch over to this.
RC, verify solar radiation limits acceptable for launch.
Verified.
Terminal count briefing. If a condition exceeds a launch constraint any time after the terminal count status check, the observer shall announce hold on channel 1, identify their station, and briefly state the reason for the hold. Flight control, perform launch on time verification.
Roger.
OSM, verify the hold fire switch is in the proceed position.
Ready to proceed.
RLM, verify the red line monitor and vent table are in the correct configuration for terminal count.
Verified.
So guys, we are now
minus
only
9 minutes.
9
LC
minutes.
performing hold authority com check. LSIC RF.
Loud and clear.
Loud and clear as well. ATD.
Loud and clear.
Loud and clear as well.
Okay, so everything is looking nominal, and guys, now finally we will be able to see the launch of the Delta IV rocket, and that's what we are waiting for around 2 hours now, right? So finally, in just 8 minutes or so, we will be able to see
Launch on time verified.
the rocket.
Roger. LC switch to the ready position. All steps are complete prior to the status check.
Okay. This looks good. Everything is looking good here.
L minus 8 minutes.
8 minutes. Okay, so guys, now the things are getting heated up, and I don't know about you, but I am very excited to see a Delta IV Heavy lifting off.
This is Delta Mission Control
I
at
haven't
T-minus 4
seen
minutes
that.
and holding. We remain in the built-in hold as preparation for launch continues. In a few moments, Launch Conductor Scott Barney will poll the launch team for the final go to pick up the count. 27 engineers and managers are polled for system status and readiness to proceed. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final polling of the launch team.
Yes, this polling is very exciting to listen, and so just guys hear and listen and see how does it feel like. I personally kinda like it because it gives a feel for the viewers, as in
L minus 7 minutes.
things are getting
Status
heated up.
check to proceed with terminal count. First stage systems, propulsion. Go. Hydraulics.
Go.
Locks.
Go.
LH2.
Go.
Second stage systems, locks.
Go.
LH2.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
GCQ.
Go.
Operation support.
Go.
Pneumatics.
Go.
Umbilicals.
Go.
HASGAS.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Ops safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicles ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count.
Here we go, guys.
L minus 6 minutes.
MEQ, establish swing arm lock pins pull.
Active.
Everything is go for launch.
Polling is complete, and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now, but before it does, let's walk through the final checks we'll hear from the launch team. Delta IV's liquid oxygen and hydrogen tanks have been full for approximately a half hour and in topping mode to replenish commodities that evaporate while we perform final valve and vent system checks. Once the terminal count begins, you'll hear indications that propellant topping has halted on all Delta first and second stage tanks. The oxygen systems are secured first, followed by the hydrogen systems, and all tanks will be pressurized for flight. The vehicle will transfer from ground electrical power to its onboard batteries. Hydraulic systems are pressurized and the vehicle's ordnance systems are armed. At T-minus 60 seconds, the Eastern Range will provide the range green call indicating that weather conditions are acceptable. All supporting assets are ready for liftoff, and the air and sea adjacent to Complex 37 and along the flight path are clear. At T-minus 30 seconds, Launch Conductor Scott Barney will conduct one final short status check to verify all systems remain go for launch.
Terminal count.
At T-minus 15 seconds, the ROFIs, or radial outward firing igniters, will light to burn off residual hydrogen around the base of the vehicle. At T-minus 7 seconds, the starboard engine will ignite, followed by the port and core engines at T-minus 5 seconds, and liftoff will occur at T0. After liftoff, you'll hear the voice of Patrick Moore with launch vehicle ascent data.
Okay. So guys, now we come 4 minutes only left from the launch to happen. I think I need to check all those timings till the countdown
This is
begins.
Delta Mission Control at T-minus 4 minutes in holding. We anticipate releasing the hold in just a few moments.
Yeah.
T-minus 4 minutes.
The countdown clock is resumed. We've entered the terminal count.
3:55.
Go for launch.
Ground pyros enabled.
Now the thing is set up. So the guys, only 3 minutes left, and behind you can see the flare stack also burning on liquid hydrogen.
Minus 325.
Excessive.
Second stage lock, secure at flight level.
I'm so much excited for this now.
Second stage liquid oxygen systems are now secured and ready for flight.
Now that means that no more liquid oxygen is being
Minus
pumped
307.
inside the oxygen tanks. As you can see, the venting has also stopped. This is purely nominal, and I am so much excited to see that fireball right now. Man.
Minus 249.
FTS internal.
Guys, are you excited? Are you excited to see this beauty lift off?
Vehicle now on internal power. First stage lock systems are secured for flight.
नवीन जी ये जा रहा है ऑर्बिट में जियो ट्रांसफर ऑर्बिट. It is going to a Geo Transfer Orbit on Earth, toward around Earth.
Minus 2 minutes.
Just
Hydraulic
2 minutes
pressure
left.
4,000.
Vehicle internal.
155.
Launch sequencer start.
Vehicle is in internal power, and I
CBC LH2 at flight pressure and flight level.
Minus 140.
FPS launch enable.
at around
137.
3 seconds or 4 seconds you will be able to see that fireball to come alive, and then finally it will lift off.
FTS armed.
T-minus 90 seconds. The launch vehicle, payload, ground systems at Eastern Range are go for launch.
Hi everyone.
Minus 120.
Just wait for this beauty to lift off
FTS
now.
count started.
T-minus 1 minute.
Yes, only 1 minute left, guys. 1
Rock
minute.
report range status.
Range green.
Range is green, and we are going for a lift off.
Minus 50.
Forty seconds.
Second stage LH2 secure at flight level.
30 seconds.
Minus 30.
Status check.
Go Delta.
Go NROL-44.
$19, 18, 17, 16,
15.
15,
Roll for
14,
ignition.
13, 12, 11,
10.
9, 8, 7, 6,
the
5,
fireball.
3, 2, and liftoff.
Oh, oopsie doopsie doopsie oopsie. Whoa. Shit.
And stand by. We've obviously had a hot fire report.
No, please don't explode. I didn't like that black fumes which came. What the hell just happened? Whoa. Whoa, guys. Literally, this thing I just don't have words right now. I didn't expect this thing. And we don't. First of all, the throttle went on to the full power, and then the thing happened. I think there is some issue with the power throttle kind of a thing.
And LC verifies MECO confirm.
Main engine cutoff is confirmed, means the engine is not running.
This is
right
Delta
now.
Launch Control. The last call from the launch conductor indicating that he has confirmed that the engines did not start.
Oh, okay.
At this point, the launch team will be securing the launch vehicle, ensuring that all systems are saved.
3 seconds. Received a TISR abort.
Roger. And are you ready to reset the clock T-4 and holding?
Roger, ready.
Roger. ALC reset countdown clock to T-4 minutes and holding.
Roger.
Okay, again and hold. At the we didn't. I have also never seen that before. That only the fireball we were able to see. That was such a beauty, but then engine didn't start it. I think what happened was
SCS in pre-flight mode.
Roger. Prop 1, verify safe RS-68 shutdown and following purge configuration.
Active, sir.
Safe.
DST-1, LC. DST-1, best source select number 4 to switch best source select number 1 and best source select number 2 force to channel 1.
Roger.
MEQ, swing arm lock pins install.
In work.
Guys, don't worry, it's not a scrub till now. They haven't announced. Let's just be optimistic. They are just looking in as in what went wrong, and we had a confirmation right now that there was a safe shutdown of the engines, and anything didn't happen. So guys, I would like to say what happened
And
from the
LC pad looks nominal. OSM, can you verify?
Okay, so now they will be verifying everything.
We're doing
like
sweeps right now.
Right.
I don't see any fires.
What went wrong and checking the
LC,
oxygen and hydrogen
installed.
levels.
Roger. ALC, establish engine cooling water off.
Actually, we only can see from the speculation what has happened. We don't know about the the internals or actually the details, right? That thing is only known by the ULA officials. But what I can tell you, this has happened during that also, the Falcon 9 launch also. There was one Falcon 9 launch, but
Water off.
this similar thing happened. So I am assuming that I could be wrong, and I think I will be wrong for this also, but what I can
LCOSM.
speculate.
OSM.
Sweep complete, no fires.
Roger. And USO, you can verify same.
USO verified.
Roger.
Actually, they are now what they are doing is the flight abort procedures, because they went from a flight.
And MEQ, LC.
Go ahead.
Did you verify lock pins installed?
Yes.
Roger. All right. Report system status, Fuel 1.
Fuel 1 nominal.
Fuel 2.
Fuel 2 nominal.
LOX 1.
LOX 1 nominal.
LOX 2.
LOX 2 is nominal.
And Prop 1.
We're still looking, sir, but we think we're nominal at this time.
Roger. Report 1 complete.
Roger.
And PNE, have you established PSN2?
Verified.
How do you know, guys? How do you know High River Racer for the spark?
HYE, secure hydraulics.
Roger.
ASGAS, establish scan pattern 305.
Roger.
GE, establish arm igniters, reset.
Reset.
PNE, verify nose cone purge on and set heater to 164 degrees.
Verified.
Oh, okay. So a terminal countdown sequencer rack which controls the countdown called an abort at T minus 3 seconds. And the launch team is now safing the launch vehicle and the pad facilities. Guys, I think
OSM, LC.
that has
OSM,
only happened.
Report ready to safe vehicle ordnance.
Ready.
The
And
speculation.
verify OSM concurrent safe FTS.
OSM concurs.
FTS, command FTS safe and external.
In work.
Wow, that was something a bit of unexpected. But yeah, I was telling you guys from the past experience and from the speculation, I can tell that the thing which happened with this was the excessive power to the engine. But I am not sure. I am again telling you that I am not sure. This is just a speculation and the past experience. Similar thing happened with the Falcon 9 launch of one Starlink mission, wherein this similar kind of an issue, wherein around T minus 0 seconds the launch was aborted because the computers detected there was excessive power going on to the engines, and that's why they had to abort the launch. And I think the issue is that only, but I don't know. Now I won't saying issue is that only. I won't say that. I'm saying my speculation is that, but I don't know. I am not an internal part of his team, and also the rocket is a
This is
so
Delta Launch
complex
Control.
piece of hardware.
As you're hearing on the net, the team is working to secure and safe the vehicle. Swing arm lock pins have been installed to ensure the swing arms will not be retracted, and all vehicle systems are being evaluated for their status. So far, all nominal calls from all of the operators relative to their systems on the ground and on the launch vehicle.
MEQ, report swing arm system secured.
Secured.
ALC on TC emergency pedal, remote cameras normal.
Normal.
PNE, configure helium supplies.
In work.
Okay, yeah, that could be the reason, guys. I don't know. Hold.
LC, flight control is ready to proceed to detaking.
Roger. LD, LC, that one.
LDL1.
LD, we had a hot fire aboard at T minus 3 seconds. We have performed our abort sequence securing. We are ready to proceed into detanking operations.
Proceed, LC.
It looked like a nice static fire, right? But this means, guys, they.
All right, team, we're proceeding to Operation 80.
Oh, that was okay.
And RC notify range of decision.
I River Racer, that's okay. I didn't get it. That's my problem.
Flight control, terminate option 910 and reset 910 flags.
Roger.
And that also means, guys, there could be problem with the
and LC to
SpaceX
1 able.
launch also.
LC go.
Yes, sir. Prop
It
1.
didn't launch today.
State systems nominal.
Roger.
There can be some problem with that also. We don't know. Let's just hope that everything goes fine.
Option 910 terminated and flags reset.
Roger. And flight control re-enable MSE Adams limit monitor.
Roger, it's going to work. MSC limit monitors are enabled.
Roger. RLM LC.
RLM, go ahead.
Stop red line monitor.
Obviously, they will, guys. This won't happen today now. obviously they will be securing the saving all those things and then putting in as in what went wrong and then coming up again.
LC flight control
And
is ready for
next
clock
launch
reset.
opportunity is
1.5 minutes.
no earlier than 31st
Roger.
August. Yes, it's detanking. High River Racer detanking is going on, and I think it is over.
ALC adjust clock to T plus 5 minutes and start plus count.
Roger.
So now today it won't be happen today. Obviously the launch won't happen, and we are just waiting for the
Pass
things
gas
to
LC.
come in properly. Let's just hope everything goes right.
LC RLM.
Go ahead.
Go RLM.
RLM is stopped.
Roger. Has gas. Proceed to scan pattern 305.
Roger.
And MEQ, we've already established swing arm lock pins installed.
Roger.
Shut down swing arm hydraulic system.
Roger.
And the most happiest thing about this is this boom didn't happen. Obviously the boom didn't happen. That's the thing. I didn't want that to happen
OSM
also.
LC.
That's the most important thing. The
For step
payload
70,
is safe,
drop
the rocket
FHA
is safe.
roadblocks and establish BDA roadblocks.
Roger.
OSM SRM ignition disable.
Just disabled.
SYS LC.
Go.
Establish T for PCM data transfer to nominal per data station PCM selection item.
Roger.
PNE LC.
Go for PNE.
Perform initial securing for step 70.
Roger.
I'm trying to
MEA LC net 1.
SIMEA, go ahead.
Yeah, can you verify FEVBS covers remain intact?
Yes, sir. They all are intact.
All 9. I just want to repeat, all 9 are intact.
All 9 are intact.
Roger, thank you. FTS LC.
Go ahead.
Step 90, secure RF, FTS, and GPS MT.
Roger.
ABE, disable EIB heaters.
Roger.
Guys, this is not good, but at least we
LC,
were able
LD
to
on
see
channel
that
1.
Go
fireball,
LD.
right? And that was so
LC,
cool.
the MD has declared a scrub for today's operation. Please
Uh,
proceed with detanking operations.
Now
Roger.
the detanking will occur. Now it will occur, and as he announced, it is a scrub for today's launch. Wow.
This is Delta Mission Control. It's now been confirmed that Delta 4 Heavy NROL-44 launch activities will not continue this morning, and a new date has yet to be identified. For the most up-to-date information, please visit ulalaunch.com, follow us at ULA Launch, or call 1-877-ULA-4321. This concludes this morning's coverage. I'm Dylan Rice. Thank you for joining us.
Wow, what happened? I don't know, but the clear speculations were that I only told you that obviously the thing happened with the T-3 seconds. We were able to hold that. The engine didn't come to power, and hence everything was secured. But why did that happen? That report can only be given by the officials. We can't speculate these things because we don't even have data to analyze. So yeah, let's just hope that next time when they will come, everything will be fine and we'll be able to see the launch. At least for today, we were able to see that fireball, right? And that was pretty cool. That was damn cool, I should say. Yeah guys, thanks for joining in, and don't worry, tomorrow also we are coming in hot with the Rocket Lab launch, and again obviously whenever this launch will occur, it is no earlier than 31st August, that's for sure. But whenever this launch occurs, after they identify the anomaly, then we will be able to stream the launch. So guys, stay safe, stay healthy, and bye bye. And yeah, don't forget to come again tomorrow. Okay, bye bye.